The universe is a vast and mysterious place, filled with wonders that continue to amaze us. Among these wonders are stars, the building blocks of galaxies, and the creators of the elements that make up our world. But where do these celestial giants come from? The answer lies in the heart of enormous clouds of gas and dust, known as stellar nurseries. These stellar nurseries are scattered throughout galaxies, often appearing as luminous patches against the backdrop of the cosmos. Within these clouds, gravity reigns supreme, drawing together atoms of hydrogen and helium, the most abundant elements in the universe. As more and more matter clumps together, the cloud's core begins to heat up under the immense pressure. This pressure continues to build until a critical threshold is reached, a point where the temperature at the core becomes hot enough to ignite nuclear fusion. This is the moment a star is born. Hydrogen atoms, forced together under unimaginable pressure, fuse to form helium, releasing an incredible amount of energy in the process. This energy radiates outwards, creating the brilliant light we observe from stars. The birth of a star is a testament to the awe-inspiring power of nature, a delicate dance between gravity and nuclear fusion. The mass of the initial gas cloud plays a crucial role in determining the fate of the newborn star, shaping its life cycle and eventual demise. Once a star ignites nuclear fusion in its core, it marks the beginning of a new chapter in its life. This process is the heart of a star's energy production, where hydrogen atoms are fused together to form helium, releasing immense amounts of energy in the form of light and heat. It enters a long, stable period known as the main sequence. During this phase, the star maintains a delicate balance between the gravitational forces pulling inward and the pressure from nuclear fusion pushing outward. This is the longest stage in a star's life, and it's characterized by the steady fusion of hydrogen into helium. The energy produced in this process is what makes the star shine brightly in the night sky. Our own Sun, a yellow dwarf star, is currently in its main sequence, a phase that has lasted for billions of years, diligently converting hydrogen to helium and providing the light and warmth that sustains life on Earth. This energy is crucial for the growth of plants, which form the base of our food chain. The position of a star on the main sequence is determined by its mass. More massive stars are found higher up on the diagram, while less massive stars are located lower down. More massive stars are hotter and brighter, emitting bluer light. These stars burn through their fuel at a much faster rate compared to their smaller counterparts. These stellar giants live fast and die young, rapidly consuming their hydrogen fuel and exhausting their life force in a few million years. Their short lives end in spectacular supernova explosions, leaving behind neutron stars or black holes. Smaller stars, on the other hand, are cooler and dimmer, emitting redder light. These stars are known as red dwarfs and are the most common type of star in the universe. These stars are incredibly fuel efficient, slowly sipping their hydrogen reserves and enjoying lifespans that can stretch for billions, even trillions of years. Their slow and steady approach to burning fuel allows them to outlive most other stars. Our Sun, with its moderate mass, falls somewhere in between these extremes. It is neither too massive nor too small, making it a stable and long-lasting star. It's been steadily shining for about 4.6 billion years and has enough hydrogen fuel left to continue for another 5 billion years. This means that our Sun is roughly halfway through its main sequence phase. During this time, it will continue to be a source of light and warmth for our solar system, providing the energy necessary for life to thrive on our planet. The Sun's stability is crucial for maintaining the delicate balance of our ecosystem. The main sequence is a period of relative stability in a star's life, but it's not without its changes. Over time, subtle shifts occur as the star ages. As a star ages, it gradually exhausts the hydrogen in its core, causing the core to contract and heat up. This increase in temperature leads to changes in the star's structure and behavior. This in turn heats up the outer layers of the star, causing them to expand and cool. The star becomes larger and more luminous, but its surface temperature decreases. The star's color changes as it evolves, shifting towards the redder end of the spectrum. This transformation marks the beginning of the end of the star's main sequence phase, as it prepares to enter the next stage of its life cycle. While massive stars grab the headlines with their brilliance and short lifespans, The universe is teeming with a far more common, yet often overlooked type of star, the red dwarf. These unassuming stars may not have the dazzling brightness of their larger counterparts, but they play a crucial role in the cosmic landscape. These stellar dwarfs are significantly smaller and cooler than our Sun, emitting a faint reddish glow that makes them difficult to detect with the naked eye. Their subtle presence often goes unnoticed, but they are the silent workhorses of the galaxy. Despite their diminutive size, red dwarfs are the most numerous type of star in the Milky Way galaxy, accounting for an estimated 75% of all stars. This staggering number highlights their importance in the grand scheme of the universe. Their small size and low mass mean that they burn their hydrogen fuel extremely slowly, giving them incredibly long lifespans. Unlike massive stars that live fast and die young, red dwarfs take their time, burning steadily for billions, even trillions of years. In fact, some red dwarfs are predicted to live for trillions of years, far exceeding the current age of the universe. This longevity means that many of the red dwarfs that formed early in the universe's history are still burning today. Because red dwarfs are so long-lived, they offer a tantalizing glimpse into the distant future of our own galaxy. As time marches on, these stars will continue to shine, providing a steady, albeit faint, light in the cosmos. As more massive stars exhaust their fuel and fade away, red dwarfs will continue to shine, becoming the dominant stellar population in the Milky Way. Their endurance ensures that they will be the last stars shining in the universe. Their faint light will illuminate the remnants of a bygone era, providing a faint but enduring glow in the ever-expanding darkness. This persistent glow serves as a reminder of the universe's enduring nature. While red dwarfs are too dim to be seen with the naked eye, powerful telescopes have allowed astronomers to study these fascinating objects in detail. Through these observations, we have gained a deeper understanding of their characteristics and behaviors. Observations have revealed that red dwarfs are incredibly active stars, frequently erupting with powerful flares that can bathe any orbiting planets in intense radiation. These flares, while beautiful, pose significant challenges for any potential life forms on nearby planets. As a star like our Sun exhausts the hydrogen fuel in its core, it embarks on a dramatic transformation. This process marks the beginning of the end for the star, a journey that will see it undergo several significant changes before its final demise. No longer able to sustain nuclear fusion in its core, the star begins to collapse under its own gravity. This collapse is a critical phase in the star's life cycle, leading to a series of events that will ultimately determine its fate. This collapse causes the core to heat up even further, eventually reaching temperatures high enough to ignite the fusion of helium into heavier elements. The core's increasing temperature and pressure are essential for this next stage of nuclear fusion. This renewed fusion activity releases an immense amount of energy, causing the star's outer layers to expand dramatically. The energy generated in the core pushes outward, inflating the star to many times its original size. The star swells to an enormous size, becoming a red giant. This phase is characterized by the star's significant increase in size and luminosity, making it one of the most striking stages in a star's life. During this phase, the star's surface cools, giving it a characteristic reddish hue. The cooler surface temperature is a stark contrast to the intense heat of the core, creating a unique and beautiful appearance. Red giants are truly gigantic, with some reaching diameters hundreds of times larger than our Sun. Their immense size and brightness make them easily visible in the night sky, even from great distances. For stars significantly more massive than our Sun, the journey doesn't end with becoming a red giant. These colossal stars continue to evolve, undergoing further transformations that lead to even more dramatic stages. These stellar behemoths continue to fuse heavier and heavier elements in their cores, progressing through a series of nuclear reactions that produce elements like carbon, oxygen, and neon. Each stage of fusion brings the star closer to its ultimate fate. With each stage of fusion, the star releases more energy, causing it to expand even further and become even more luminous. The energy output during these stages is truly staggering, illuminating the star's surroundings with incredible brightness. These massive stars eventually evolve into supergiants, the largest and most luminous stars in the universe. Supergiants represent the pinnacle of stellar evolution, showcasing the incredible power and complexity of these celestial objects. Supergiants are characterized by their enormous size and intense brightness, often shining with the brilliance of millions of suns. Their sheer scale and luminosity make them some of the most awe-inspiring objects in the cosmos. Betelgeuse, a red supergiant located in the constellation Orion, is a prime example of these stellar titans. Its immense size and brightness have fascinated astronomers for centuries, serving as a reminder of the incredible processes that govern the life and death of stars. In the vast expanse of the universe, there exist colossal entities known as stellar behemoths. These massive stars dwarf our own sun in both size and luminosity, shining as beacons in the cosmic ocean. Their lifespans, though relatively short on a cosmic scale, are marked by incredible power and brilliance. As they near the end of their life cycle, these giants often explode in spectacular supernovae, scattering elements across the galaxy and seeding the cosmos with the building blocks of new stars and planets. Among all the celestial bodies, one stands out as the reigning champion, the supermassive black hole. These titanic objects reside at the centers of most galaxies, including our own Milky Way. Their gravitational pull is so intense that not even light can escape once it crosses the event horizon. Despite their fearsome reputation, supermassive black holes play a crucial role in the formation and evolution of galaxies. By studying them, scientists hope to unlock some of the deepest mysteries of the universe. Imagine a star so massive it challenges our very understanding of physics. These colossal giants, often over 100 times the mass of our Sun, push the boundaries of what we thought possible. Their immense gravity and energy output create conditions that are, quite frankly, extreme in every possible sense. When we look up at the night sky, it's easy to feel small. The vastness of the universe is truly mind-boggling. Each dot of light represents a star, many of which are far larger and older than our own Sun. It's a humbling experience, realizing just how tiny our place in the cosmos really is. Stars are born in clouds of gas and dust, known as nebulae. Over millions of years, gravity pulls these particles together, forming a new star, but the story doesn't end there. As stars exhaust their nuclear fuel, they can explode in a brilliant supernova, scattering elements across the galaxy. This cycle of birth and death is what seeds the universe with the building blocks for planets and life. So, where do we fit into all of this? Our Sun is just one of billions in our galaxy, which itself is just one of countless galaxies in the universe. Yet, despite the vastness, we have a unique vantage point. Our curiosity and drive to explore have allowed us to uncover the secrets of the stars, and in doing so, we've learned more about our own origins and our place in the cosmos.